everyone. Thanks for joining us today. We're going to give everybody just another 30 seconds or so to join. Have a bunch of people floating in, so we'll be starting here in just a minute. All right, good afternoon or morning, depending on where you're joining us from today. Thank you for taking the time to join us for our webinar event, Turn Your Snowflake into a Cloud-Native SIEM with Panther. I'm Krista O'Brien from Snowflake and will be your host for today's event. I'm joined by a few friends today, Omar Singer, Head of Cybersecurity Strategy at Snowflake, and Jack Naglieri, Founder and CEO at Panther Labs. We're excited to have you all with us today, and we hope you find the content valuable. A few housekeeping items before we get started. If you're experiencing any issues with the slides or audio, please try refreshing your browser. Also, all lines have been muted, so if you have a question, please put it into the Q&A box on the right-hand side of your screen, and we'll answer them during the Q&A portion at the end of the presentation. We have also loaded some relevant materials for you in the Resource tab at the right-hand side of your screen for you to view, download at your leisure. After the event, there will be a brief survey if you have a few minutes to tell us how we're doing and what you'd like to see more of in the future. Additionally, you'll be receiving a link to the recording of this presentation in your email inbox tomorrow. Today's event will include an overview of the challenges facing cybersecurity teams today, followed by an introduction into Snowflake and Panther, with a deeper dive on how our two companies come together to solve those challenges, and concluding with a live demo and, again, Q&A. So keep those questions coming. And with that, I'd like to introduce our first speaker, Omar Singer. Omar, take it away.
All right. Thank you, Krista, and thank you all for joining us today, spending some time with us. I'm going to start by talking about some challenges that security teams face with their SIEMs. And I faced these challenges myself when I joined Snowflake over 2 years ago and joined to lead the security engineering organization. And this first stat that you see here is the average cost of a security breach. But when I joined the security team at Snowflake, it was clear that any security breach wouldn't be measured in $4 million or $40 or $400 million. Customer trust in Snowflake, customers trusting us with their most sensitive data is priceless. So really, we looked at this as a zero-fail kind of situation. And from a SIEM perspective, we have to be able to spot the threats that we're facing and be able to respond to them effectively when they do come through. And so recognizing that, we then look to see, well, what is the problem, size of the problem in terms of how long do we need to have the data? How long will it take us to detect a breach? And it's really measured in months and months. And I looked at the SIEM solution that we had at the time, and some of the data would be saved for 5 days, some of the data 30 days or 90 days. But clearly there would be this gap. There would be a real challenge in being able to investigate an issue when it's detected. And what's making that challenge worse and worse, harder and harder, is this trend that data is growing very quickly, especially as companies move from on-prem infrastructure up to the cloud. Just the volume of data that they're generating and that security teams need to monitor, it's growing by 10x. And this is a trend that's just continuing, and it becomes a real challenge. To kind of put it in perspective, there was a study that said 90% of all data was created in the past 2 years alone. And so if we're thinking about data like activity logs, asset inventory, configuration records, we need to have visibility into all of that, and it's growing so quickly. Traditional SIEMs were not built for this volume of data. We see that traditional SIEMs often price on a per gig basis, and the scale in terms of cost and overhead forces teams to put in place all sorts of workarounds. I'll show you an example. Here's an example of the kind of workaround that security teams are facing today. Anybody that's had to manage growing data sets that are exceeding what their SIEM can handle might see this and recognize it, might feel either nauseous or angry or both, but this is kind of the state of the art today. And before we talk about cloud native SIEM technology, let's understand what we need to deal with when we're not dealing with cloud native SIEM technology. The traditional SIEMs have all these different workarounds for hot data, cold data, frozen data, and it's on the security team to manage all of that. And when I talk to Snowflake customers, they ask how can they use Snowflake to help them in their mission, because dealing with this is just so hard. And it's not, this isn't even just the only way in which this is manifested. You also see security teams now just dumping data in S3, for example, where it's now a new silo and it's not going to be searchable in the same queries that they do. So there's this real challenge. And as the data volumes are going to continue to grow, this challenge is just going to get bigger and bigger. It's going to get harder and harder. And that's really pulling Snowflake into this space, because there must be a different alternative. The more cloud-centric that our companies are, the more important it is to have a cloud-native security architecture. And so let's look at the Snowflake platform and how it addresses some of these challenges of just dealing with scale. First thing to notice in the Snowflake architecture is that core storage element. Snowflake uses cloud-native storage, so in AWS, that's S3 to store the log data, and that has infinite scale to it. So you're not going to fill up S3 no matter how hard you try. It doesn't matter if you're generating 100 terabytes a day, you're going to be able to put all that data into S3. And this is also very cost effective. So for this centralized storage that Snowflake brings for security teams to use, the cost is $23 a terabyte a month. Snowflake also compresses the data. So in this architecture, you're able to store as much data as you generate without needing to worry, is it too high volume? Is it too verbose? How long do I keep it? Really going away from all of that with that centralized storage. And that's the key kind of difference between a traditional SIEM and what we call a security data lake, is that separation of storage and compute. There are no servers that need to scale out just because you're trying to store more data. In addition to separating storage from compute, Snowflake also separates compute from compute. And that's that next level that you see in the Snowflake architecture. The idea is by using Snowflake to hold the security data, what you can do is you can have these different compute clusters that are totally separate from each other. So as you are writing more data into Snowflake, you use one compute cluster for that, and a separate compute cluster for workloads like investigation queries. And when it comes to threat hunting or BI visualizations, those can get different compute clusters as well. Each one is totally separate. Each one's cost is tracked separately, and there's a benefit there. And when a compute cluster is not being used, it goes to sleep. And from a security perspective, that's really important, because we have security teams that some operate 24/7, but certain roles are definitely 5 days a week, not working on weekends or vacation time. And then cluster goes to sleep, and that unlocks very substantial savings. And the third layer, the cloud services layer, is how Snowflake adds elements like role-based access control. So if you're just trying to dump these logs into S3, for example, it's going to be very hard to choose who has access to what. And Snowflake enforces that in this cloud services layer. This is also where the support for semi-structured comes in. Semi-structured data like JSON is kind of the standard now for how logs are generated. And being able to query that JSON is essential for security teams. In fact, this is why the traditional data warehouses were not used by security teams, because they expected the data to have a very consistent schema, and security data is just not like that, right? It changes, and there's all sorts of different formats to it. But Snowflake can handle that with its native JSON support and schema on read. And so in the Snowflake security team, we've been loading security data into Snowflake for a while now, and it was very It was very successful. We've been able to really consolidate our whole program on top of Snowflake. But we needed to spend months of engineering work to make that possible. And that's because this data lake use case is a core use case for Snowflake. And you can see that here among the different use cases that Snowflake supports. The data lake is one of them. But there are a lot of security-specific elements that we needed to build, and some Fortune 100 customers built as well. But I'm so excited about this partnership with Panther because now every Snowflake customer can look at addressing all the pains of traditional SIEM, the ballooning costs, the overhead, meaning to pick and choose which data sets they can collect with the help of Panther. And so really excited to hand things over now to Jack, CEO of Panther, to tell you more about their platform. Jack?
Awesome. Thanks, Omar. Hey, everyone. Good morning or afternoon or evening, depending on where you are in the world. I'm going to walk through a little bit of who we are and how we got started. So back in 2018, I founded Panther Labs after spending about 8 years as a security practitioner for companies like Airbnb, Yahoo, and VeriSign. And during those years, I faced a lot of the fundamental challenges that Omar was just talking about around the collection management and analysis of huge amounts of security data that was needed for me to do my job. And over time, as we moved from the larger monolithic companies to the more nimble cloud-native companies, this need to evolve from the traditional SOC into a cloud automation-first approach became really necessary. And when we founded Panther, we have the mission of stopping cloud-based breaches by providing a modern cloud-scale visibility platform. And we built Panther based off of the years of this internal experience that we had in security teams at Amazon, Airbnb, and some others. And our whole thing is we want to make sure that we're future-proofing the SIEM industry and providing a solution that all teams can use to do this sustainably. So good visibility starts with good data. And on the left side of our diagram, we really start with the logs that we need to collect and care about as a security team. So we can pull directly from APIs, from tools like Okta or from a login. And we can also read data from our on-prem systems, from our clouds, from our network devices, things like that, by choosing to aggregate into cloud-native storage systems or messaging systems like S3 or SQS. And what happens is after that aggregation occurs, what Panther does is we take the raw security data, we parse it out, we normalize it, and we run detection based off of the built-in rules that come with Panther, but also the rules that you define as the security practitioner. A big thing with Panther is we love flexibility, and we love building detections as code. And then what happens is the data gets persisted into your Snowflake, where you can do all of your investigation, all your threat hunting, and you can actually join with the other data that you have in Snowflake to build context and answer questions that were previously really hard to get to. And then any alert that we generate gets sent out to our team, whether it goes to an incident management solution like PagerDuty or Jira or a orchestration-based platform for taking the response to the next level. And then finally, another huge benefit of partnering with Snowflake is that there's a number of BI tools that can pull the data from Snowflake to build custom visualizations and dashboards and things that are important to you. So let's understand a little bit more about Panther. So, why is Panther and Snowflake really a great combination? Well, the first thing is that with them together, you get, as a security team, real-time detection on top of your data lake. This is a newer-ish concept in security, but we're seeing that teams really love the quick responsiveness of getting an alert right when badness is occurring. And then the second piece is, with Panther and Snowflake together, this previously unstructured and really difficult to use security data now becomes structured JSON, which is what Omar was talking about as a huge strength of moving to a data lake is, having this normalized data at your disposal in a consistent schema. And this gives you sustainability over time. It gives you better cost structures, better performance, and you're able to do queries that weren't previously possible. And that really leads to scalability of using a data lake, which is, it's basically zero ops. And, previously in the roles that I was in, I had spent so much time on operations as a security engineer when that time could have been spent on building out better detections, interfacing with other tools, and allowing me to do my job as a security engineer better. Finally, a huge thing with...
And Jack, just to build on that extreme scalability point, I think, it's worth mentioning just in preparation for this demo, you guys loaded a few terabytes of security logs into Snowflake.
Yes.
Nobody really noticed. This wasn't something that you needed to prepare for or, build anything out for it. And I think that speaks to the scalability of the storage. And on the compute side, the fact that, Panther behind the scenes, you're using Lambda functions to analyze the data as it's streaming through. So that can just scale as far as you need it. And when somebody is querying the data in Snowflake, imagine a situation where there is an incident and you want to crunch through the last few years of server logs and you need that to come back quickly. With Snowflake, you have the ability to say, I'm going to take this warehouse and with one click, I'm going to move it from a medium size to double XL. And that means that you're quadrupling your query power with a click of a button. That's what cloud native enables. I think that's really the exciting message here is we're taking things that have solved data challenges at petabyte scale in the BI world, and we're introducing them into cybersecurity. So in cyber, we don't need to use sort of these custom, separate, and less powerful data solutions. Let's use the best of breed from the data world to solve our cybersecurity challenges.
Right. And the final big benefit with using Panther and Snowflake together is that you get detections as code. So in Panther, all of the detections are Python functions. And again, we have a number of rules that come built into the system. So you don't have to start from scratch. And we also provide guidance to our customers around onboarding their previous rules in their other systems into Panther and helping them get going. But detections as code is really important because it allows expressibility, testability, and more importantly, repeatability, and just improving confidence that when an attack happens, we have a rule that will actually fire an alert. So there's two deployment models for running Panther and Snowflake. The first is a fully cloud SaaS, where there's zero operations on your part. Panther is hosted within a single tenant SaaS environment, so your data is never commingled with any other user. And this just allows you to get up and running as fast as possible. The other option is what I call cloud prem, which means we help you deploy Panther within one of your Amazon accounts, and we guide you through upgrades and maintainability over time. And this has the benefit of privacy, right? The data will always remain within your Snowflake and within your environment. But the way we connect to Snowflake is the same. The important thing to remember is we write it out all to your Snowflake cluster. So now I'll walk through a demonstration of how all this works together, and then you'll get to see firsthand what this experience is like. So let's build a scenario. Let's say we have a company called Acme Corp, and what they do is they manufacture custom face masks because we're trying to stop the spread of this pandemic. And let's say they run their entire workload on Amazon. So, they have hundreds of employees and a lot of developers and changes being constantly pushed. And let's say, theoretically, one of those API keys gets leaked onto the internet. And let's say an attacker gets a hold of this key and starts to enumerate around this environment. And then let's say they steal some data. So let's detect this with Panther, and then let's do our investigation to understand exactly what happened with Snowflake. So every good incident response program starts with proper preparations. And as I mentioned a moment ago, Panther comes built in with about 200 pre-built rules and policies across frameworks like CIS, MITRE ATT&CK, and then some internally researched best practices and patterns that we see in the wild. And these packs cover logs for all of Amazon. So CloudTrail, GuardDuty, S3, the really important ones that you would want as a security team. And then other things that I mentioned in the slide prior around, these are our data sources on the left side. So Okta, OS Query, like your host logs, et cetera. And again, we help you, the customer, get onboarded into Panther and help convert some of the previous detection logs that you had into Panther rules. So because we have these built-in rules running, for example, we have a built-in rule around detecting reconnaissance actions. And we also are looking to see if there's permissions denied. Because generally, if you're scanning for permissions, you'll have some hits that go through and some that don't. So now that we have this rule running, me as the attacker, I fire up my Python script that enumerates around permissions. And I test to see if I have database access. I test to see if I have S3 access. And then I find that, oh, interesting, these keys actually have read-only permissions, or at least to list tables on a table called Acme orders. That's interesting. And then more interestingly, we see we have access to some buckets. So one's around financial data and the other one is around customer data. Okay, this is a good finding as an attacker. But because we have Panther running, we're detecting this activity. And we see that we had a high throughput of permission denieds around these recon activities. So what we want to do is start investigating and build our confidence that this is actually bad behavior and we need to do something. So what happens is when we click into the Panther UI, we get an alert overview. And the alert overview will give you all of this metadata around what has just happened. So we get our title that we saw in Slack a moment ago, which gives us a one-liner of what's going on. We get our alert ID, which I'll use in a moment. And then we get some other information around the way that we group our alerts. So this thing called a dedupe string, deduplication string, controls how we organize the alerts. And this really helps with reducing a very high number of alerts. So instead of a single alert per event, oh yeah, Omer, go ahead.
No, Jack, I just wanted to say about that one, having gone through the experience of trying to build some of this functionality on top of Snowflake internally, this is the sort of thing that you can spend weeks on. Definitely all security teams are overstretched, too many alerts, right? It's cliche at this point. But if there are 1,000 alerts on some issue, and maybe it's a false positive, and maybe it's not, in any case, you want that to be condensed into as few alerts as possible so that the team doesn't sort of miss the important signal when it does happen. And needing to build out functionality like deduplication is a challenge. And when you're considering, well, okay, I want to go cloud native, but do I want to buy this capability or do I want to try to build it in-house? This is the sort of functionality that's really nice to be able to get just off the shelf and be able to have it working well on day one.
Yeah. And again, this is fully customizable. You can set this to be whatever you want. If I wanted to group this by the IP address from our attacker, we could do it that way as well. But in this particular rule, we find that using the user ARN seems to have the best results with the least amount of true alerts. So the last thing to note here is this created at and last matched at times. This is what we're going to use to start our investigation. So let's do exactly that. So what we'll do is we'll respond by going over to the Snowflake UI and then beginning our investigation. So let's do that. Omer, is my screen coming across? Does that look good?
Not yet.
There.
There it is. Yep.
Perfect. So what I'm going to do is I'm going to take this alert ID from the Panther UI. I'm going to paste it in here. And this is a pre-canned query that we share with all our Panther and Snowflake customers, which essentially will tell us show me all the events related to this alert. And we're going to use the time frame just to make sure that, we're absolutely looking at the right data. So we'll pull in.
And while you're copying that in, just for anybody that's been in Snowflake, you might be asking, well, why doesn't my Snowflake look like this? What we're seeing here is our new Snow Site interface, which has all sorts of great features like autocomplete and that coloring and some built-in visualization capabilities. So this was released earlier this month and really worth checking out as you're using Snowflake with log data especially.
Yeah, it's nice. I really like it. So this first query will give us a view into the events that are related to our alert. So what we see are a bunch of access denieds. And if we look at the event name, which is the action that they were trying to do, we see them trying to do some IAM calls. So get user, this will tell the attacker, what are the policies attached to this access key that I have? As in, what can I really do here? And then some other things that were denied are around describing database clusters, listing users, listing groups, just general enumeration around the environment. So what we want to do next is, these are all the access denieds, but let's actually start tracing back some more information. Like, I want to know as a responder, what's the IP that this attacker is coming from, so we could start to map around and see in our data if there's hits elsewhere. So this query that I'm running now will tell us the distinct set of IPs for this user within this time frame. So now we see, okay, we have a kind of a random internet IP, and we as the security team generally have a good understanding of our IP space, and let's assume that this is a IP that we don't know about. So let's continue our investigation now with this data. So now that we have the IP, what we can do is we can search through the terabytes and terabytes of data that we've been collecting, and this will essentially tell us, show me all the first seen dates for this IP across all of my logs. And this is made possible because of the way that Panther lays the data out. So what we do is we create a view, which is essentially metadata across all of your logs. And that metadata has the standard fields that we pull out, like IPs, ARNs, host names, domains, hashes, everything. So now, we basically just queried over terabytes and terabytes of data in, about 20 seconds. And, this is really critical during an investigation as well. We need to know, when did this first start happening? We have our detections in place, but there may have been things that had happened prior to that. So now what we know is, we first saw some CloudTrail activity and some S3 activity, around the time of our alert. Our alert was around 6, and this is in UTC. But funny enough, we actually see the first CloudTrail activity is 1. So this means that the attacker was in the system before we, a couple hours before we knew about it. But also we see some VPC flow log and some ALB traffic back, 3 days prior, which could actually show network scanning or things like that. An attacker just trying to probe our network and see what they can find. So maybe that resulted in the key getting stolen. But I think what we'll do now is we'll focus on the CloudTrail and S3 server access logs, because those are the more critical sources where damage can actually be done. And we have high confidence that that's occurred. So now what we do is we're continually building more and more. So now that we have the first seen timeframes, we'll start to use that as our date range. And what this will do is this will tell us all of the API calls that the attacker made that were successful. So now what we see is some of the things from our screenshot. So if you recall, we saw list tables, list buckets, things like that, from the attacker console. And that's exactly what's reflected here as the responder. So now we look to see, okay, interesting. They listed objects in our process customer data bucket. That is scary. We need to go take a look at that. And if we look at some other things that happened, we don't see too much else on Dynamo. We don't see, any create or delete calls, and we can actually search for that like this. So we see no creations, we see no deletions. And this is really important too, because generally, creation will imply persistence, and then deletion will imply, some sort of destruction of our environment, which in both cases is really bad. So now we have higher confidence that this key had read-only access, which is still not great, but it didn't have more permissions to create a bigger impact to the business. So with this, let's actually pivot over to our S3 data. So, right here, we're looking at the CloudTrail table. And I want to note again that all of the data sources are separated by table, and they're all partitioned and very well structured, which gives you the benefit, of performance and sustainability over time. So what I do now is I switch over to the S3 server access data, which has a lot of really awesome information about how these requests to S3 are being made. And if you actually want to learn a little bit more about how these logs work, Panther, we did a webinar about a month ago. So you can check that out on YouTube as well if you want to dive deeper into how this all works. So what this query is doing is we're looking at the requester, which is our compromised user. We're again searching for requests from that IP address. And then we're looking at our date range and we see, they access these 2 buckets. So that's not great. Let's get a little bit of a deeper view. And this is a distinct call. So this is just saying, I want to understand everything that they touched. This final query here will tell us exactly what objects were successfully taken. And now what we see is 2 pieces of financial data were leaked out. So now, we've essentially hit our dead end.
And Jack, just before you move on from this, I want to call out something here, because this is so substantial, and it's also an example of how we're talking about more than just cost saving, right? So we talked about how when you're storing the data in this cloud native storage, you can save a lot, $23 a terabyte a month, usually works out to over 80% savings, which is awesome. But as a security team, you'll get the budget for at least the basics. I think the important thing here is that you're also getting much better capabilities, because being able to track object level activity for S3 is something that generally security teams, they just don't have. I talked to dozens and dozens of Snowflake customers, their security teams, and we talk about what data sets they have been able to collect and what they need to kind of leave on the table. And while CloudTrail collection is pretty standard, generally security teams are not collecting object level access logs because it's too high volume. This generates a ton of data. And if you need to pick and choose which data set, you're probably not going to take this one. But look how substantial it is here in this case where we simulated a cloud breach. We're able to say exactly which files were stolen from our cloud environment. And as a responder, that is just totally going to change the kind of response I can give to my management. Because my boss, maybe that's the director of security, he needs to tell the CISO, who needs to tell the CEO, who needs to tell the customers, what was the impact of this breach? And if we don't know, if all we can say is somebody got into our cloud, we may need to notify all of our thousands of customers that, look, we had a breach and we've contained it and we sincerely apologize. On the other hand, if we can show to ourselves and to law enforcement and to customers when they ask exactly which objects were actually stolen by the attacker, we may be able to really limit who we need to notify. Maybe instead of needing to notify thousands of customers, we can determine that only a handful of customers were affected, and then we notify only those customers. And it totally changes the impact to the company of this breach. And so here we can see how the cloud native approach to SIEM really leads to much better outcomes, not just substantial savings.
Yeah, exactly. And the last 2 things I want to note is, as we've been doing these queries, we're still loading about 16,000 records per second into Snowflake. So this should simulate a pretty substantial workload that you would see in the wild. And additionally, as I mentioned before, because there's so many integrations with Snowflake and BI tools, what we can do is we can start to build custom dashboards on whatever we want. So, this could be within Tableau, it could be really within any BI tool. They all, have slightly different ways of working, but achieve the same result. So this is a sample dashboard that I created that, gives us operational insight into Panther. And, you can see, there's a huge amount of CloudTrail data coming across. And then, we can also get some insights into that data as well. So we can understand like things about OS query, things about CloudTrail, things like that. And this could help even reveal some interesting patterns for you to create rules about, which is a common thing. And then on the bottom, we have some, Panther ops related things. So understanding the latency between the actual event times and them hitting Panther is really important. And we can see for certain log types, it's really, generally pretty low. And then for certain log types, it can be a little bit higher. So it's really helpful to understand that from an operational perspective. So now that we have answered all the questions that we need to, generally the security team would move into, remediation, containment, things like that. And, one way we could do that is just by getting rid of this access key and maybe deleting the user altogether. And maybe starting to go through and tighten up bucket policies, things like that. But also what we can do is post-incident, or you can actually even do this during the incident if you wanted to. You can create a real-time rule with Panther that would detect any other activity to that IP address. And the benefit of that is that you get a really quick feedback loop to search through these logs as well. So if you notice, what we were doing is we were actually searching over alerts that were generated from our real-time pipeline. So it's extremely powerful in how you go from a Panther Python-based rule into an investigation using SQL. And then, eventually those are going to become chained together to where you can schedule a SQL query that can get analyzed with your Python rules. So because we take this automation and, code-based approach, there's essentially limitless ways we can start to do detection. And there's also more and more features coming within Panther that will simplify a lot of, even having to write these queries, So then you get the benefit of having a simpler search interface, but still the power of Snowflake behind it. So we're really excited about that. So just to recap a little bit of what we talked about in this scenario. So what we're able to do is use these Python-based rules to detect our attacker behavior. And this is actually a built-in rule that is also open source. And we were able to pivot into Snowflake, do all the queries in SQL, answer all the questions that we have as a security team. We were able to extract IOCs out of these events, correlate them across all of our logs, and get the response back within seconds, not hours and days. And then, we contained the incident and then created a way to detect this again in the future. But most importantly, we have the tools at our disposal now to keep our companies safer. And I'll hand it back to Homer.
Yeah, let's kind of just recap what we talked about today. When we started talking about the explosion in the data volume, and that's being driven by the move to the cloud. The cloud is so heavily instrumented. Every little move you make can result in a log record. 10x increase in log volume being sort of the kind of growth that you need to plan for and build for, and driving security teams to consider a cloud-native solution, right? The cloud shouldn't just be presenting challenges to security teams. Let's also start seeing some benefits from cloud as we try to protect our companies. And with this joint solution between Panther and Snowflake, what we get as a security team is very cost-efficient, long-term storage for all of our data. Cost-efficient, typically savings are going to be around 80%. And that's even after we bring in additional data sets, way more data sets like S3 activity at the object level, which usually we don't have. Being able to store it for very long, because we have that separation of storage and compute, we don't need to increase the size of our solution just to collect more data. The data stored in S3, and we can keep data there for a long time. We can create a task in Snowflake to rotate the data out after a year, 3 years, 7 years. It ends up being very cost effective, even at the petabyte scale at which our larger customers are now running their security data lakes. There's zero maintenance overhead. So once you load the data into Snowflake, the partitioning, making sure that it's ready to query, that queries are going to be fast, the compression, the encryption, all of that is applied with zero maintenance overhead to you Everything is as a service. And from Panther, the data lake is normalized. You have a partner to make sure that the data comes in. It's going to be coming in a way that's normalized. It's going to let you pivot across specific observables. You're going to be able to analyze cloud logs, firewall logs, application logs, all in a consistent way. That's going to power threat investigations. And by the way, once you start having this data in Snowflake, you're really building out a security data lake that can serve multiple functions. That same data that you investigate in response to a Panther alert can serve a threat hunting team that now can run these very advanced analytics across the years of very verbose data, and also security metrics. Having this data in a data platform means that now you can check to see, well, where do I have visibility gaps? Automatically detect those, have them be visualized in a BI tool. Automate a lot of the compliance evidence gathering. So you probably have auditors saying like, hey, prove to me that you have an agent on all your servers by like, let's pull up this server and check to see that you really do have that security agent on that server. Why wait for that audit? If you have all the log data and asset inventory in Snowflake, you can automatically run those sort of audit questions and know exactly how you're doing and not wait to fail an audit. So there's really a lot of places to where you can take this. And with Snowflake and Panther together, you're getting really the best of breed solutions for this threat detection and response use case at cloud scale. So it's going to work fast, and it's also going to work in a year and 2 years from now and not leave you scrambling to figure out additional solutions. Let's figure out what else we need to tack on just to keep up with the volumes of data and the different types of data that are being generated. Yeah. So definitely suggest giving this a look and a shot. Jack, how would somebody get started?
Yeah, it's super simple. Just shoot us an email. We will provision a demo environment, and then we can set up a POC. Pretty simple. Just email us at sales@runpanther.io. And yeah, really looking forward to working with more and more teams and really helping them with these challenges that most security teams are facing. So I think with that.
Yeah, and I'll just share, like I work with Jack and his team at multiple Snowflake customers, and they're professionals. These are folks that have seen this problem from all sorts of different directions. They've had to solve this themselves, and it's just great seeing them work with security teams at Snowflake customers, for many of which this is new. This is their introduction to Snowflake. They didn't even realize that they were Snowflake customers, because this was before just for the data team, the BI area. And now this is sort of the introduction of the security team to the data platform. But the Panther team is very engaged, very hands-on, and makes it easy. And of course, on the Snowflake side, we're supporting it as well. So this shouldn't be something that's scary. This is something that definitely can be done, and you can start reducing the costs and improving security tomorrow or even today. So with that, let's take a look at some questions, and saw some questions coming in, so keep them coming. We will go through them, and okay, great. Looks like there's a good volume. So, Jack, do you see Kyle's question on top?
Yeah.
All right, cool. Let's start with that one. How does Panther price?
So we essentially take a holistic approach, looking at the organization size, and we look at the usage of the product. But the thing to keep in mind is that we're coming in at least 50% cheaper than the Legacy SIEM right now, and we're able to scale much higher than that. So happy to have a conversation more specifically about pricing if you want to reach out to us.
Yeah, and the key is it's not based on gigabyte, right? So if the data volume will increase substantially, that doesn't translate into higher Panther cost. Snowflake cost might increase a little bit as there's more data stored, but really that's a small part of it. And when you'll see costs increasing on the Snowflake side would be more, well, are you running more types of analytics? Did you just hire a threat hunter who's now spending 7 hours a day running queries against the data? But then the cost is tied to the value you're getting rather than just how much data your infrastructure happens to generate.
Mm-hmm. I'll take this other question from Brooke. How is real-time data handled in this case? What is the latency to make the data available for analysis? Yeah, these are great questions. So the way that real-time data is handled is, I mean, everything streamed into Panther is analyzed in real time. So that has to do with the latency from the data source. So for example, with S3, as soon as we get that notification, we pull the data in immediately. But sometimes S3 will buffer the data in a way that makes it more efficient to store. So the thing to keep in mind is, the latencies are between generally like a couple minutes, or maybe like, depending on the source, it could be 20, 30 minutes. It really varies. Every data source is different in how they buffer. And then the latency to make the data available for analysis, again, it's also picked up right away and pushed to Snowflake. So I would say within, 15 to 20 minutes max.
Yeah, and usually we see even less. I think 5 or 6 minutes is what we usually see in terms of showing up in Snowflake. I want to answer Kyle's question around what can Panther do that Splunk cannot. Let's just talk about one thing, which is kind of the clearest answer is Panther runs on top of Snowflake and Splunk does not. I think that's like the biggest difference from my perspective, at least from the Snowflake perspective, regardless of everything that Panther can do, and I'm sure Jack can go into it. But I think the key thing to get here is that Splunk does not separate storage from compute. And so there are all these different challenges and tricks that you need to do to try to keep up with the explosion in the data volume. While Snowflake has solved that problem of using cloud-native storage as the place where the data lives, separates storage from compute. And so Panther really enables you to take advantage of that.
Right. There's a lot of questions about visualization. So let me, just answer most of them. So someone had asked, what was the tool that I used to build that dashboard? That was Sigma. And someone had asked if I would open source it. I'm more than happy to make it freely available. I can do it after this call. And then I think someone had also asked, does Snowflake have a visualization layer? And I think the answer to that is really around, Omer, I can let you actually take that.
Snowflake customers will have a BI that they use, whether it's Tableau, Looker, Power BI. This is where the security team can kind of ride along. If your company is a Snowflake customer, you have a BI solution that works on top of Snowflake. This is also an opportunity for collaboration with the data team. Marketing teams, finance teams, they've been working with the data teams for a while now. And there's this huge revolution, there's a renaissance of data analytics and data science. And I think, us in cybersecurity, we've been kind of left behind. We like to think of ourselves as super technical and we can solve all this ourselves. But actually, here we have an opportunity for partnership. Security teams should focus on knowing which questions to ask, being the subject matter experts. Go and research what an attack in like lateral movement in Kubernetes, what does that look like, right? Let's go and research that. And then let's take our understanding of the subject matter of the domain of the questions that need to be asked and partner with the data team to get the kinds of visualizations that will help us to answer these questions quickly, to get the kind of data analytics in place, create baselines and anomaly detection, et cetera. Like there's a lot of, you could take this just so far in partnering, like very far in partnering with data teams. And that's the approach that we recommend. Though BI tools like Sigma Computing, what Jack showed, are easy to use. It's kind of like Excel spreadsheets with nice charting and graphing capabilities, but running on top of Snowflake. And within Snowflake, I've seen members of our GRC team that are not computer scientists, not data scientists. And once the initial connection is established, it's kind of drag and drop. And they're able to build these beautiful visualizations, automate a lot of the governance and compliance tasks, for example, on top of the data in Snowflake.
Yeah, there seems to be some questions about data onboarding, so I think I'll address those. So the way that this works today is, we have predefined schemas for the most common log sources. And very soon in Panther, what you'll have is an ability to define custom schemas for your own internal sources. So we try to cover, the 80% of what everyone's doing. And then the last 20%, we generally work with those customers or users right now and get the data in the right format that they need. But, as I mentioned, we'll have this capability built in natively to Panther, so you don't have to approach us at all. I think that covers most of the onboarding things, but okay, there's actually a question on what it takes to ingest new data sources. I mean, a lot of this is just making sure the data can land in S3 or SQS, or it's from a SaaS-based API that we support. And again, we're continually adding more and more of these. So, we hope that, within, as the company goes on, we'll have support for the most critical ones that security teams need.
Yeah. Yeah, and for on-prem data, by the way, like we used AWS example, but definitely be thinking about on-prem data sources as well, firewalls, network devices, Windows server logs. There are lots of different ways to get that into the cloud. Tools are like Logstash and FluentD are open source, free. And you can just kind of sprinkle those in the data center. They listen for syslog and they write to S3, and they write to S3 in JSON format, and from there it all kind of streams in. Panther pulls it, analyzes it, and then writes it to Snowflake. So definitely this is for the on-prem log sets as well.
Yep. And then I just answered a question about integrations. They're listed in our documentation. Okay,
Jack, I think here's a good question to answer. John from Domino Data Lab is asking, Snowflake feels great for larger teams. How quickly can a small or very busy team see value in Panther without the time to customize Python? So let's talk about this, because this is really look, for a few years now, we've seen Snowflake customers picking this up for the security use case, but it has required larger teams. That's, I think, a big part of the promise of this partnership, right? So how do you see Panther enabling smaller security teams that are strapped for resources to take advantage of what Snowflake has to offer?
Yeah, so I mean, a lot of it comes down to the built-in rules that we have with Python, the built-in Python rules that we ship with Panther. So, out of the box, you get support for all the CIS benchmarks around AWS, around, MITRE ATT&CK framework for the log sources that we support. And then this gives you a really strong baseline to really, tune and add your own and use as samples for your own internal logic. But again, also what we do is when we're onboarding new customers, we work with them to set up some detections based off of their internal business logic that they care about. So let's see. There's a question about the, from Kyle from Thrive. Can you explain the customizability of Panther versus Splunk and why? Yeah, I mean, the customizations are really around the rule sets. I mean, that's the biggest thing. The query language, I mean, we're standardizing in Python, and then that gives the benefit of being able to test the code, being able to express whatever you want without a very proprietary and difficult to understand language. But the other thing with Python that's great is, once you establish these patterns, you can define them in helpers and then you could reuse them across other rules. So, and then asking around the deduplication functionality. Yeah, I mean, it's, as Omer was alluding to before, the alert fatigue problem is one that we've seen in a lot of legacy SIEMs, and, the grouping and having the ability to group however you want can just control the way that your team gets alerted. And, Panther has some additional features around thresholding and things like that, that would allow you to further reduce the false positives and, the amount of times that the team gets paged.
Mm-hmm. I see a few questions about Google Chronicle and Azure Sentinel. So I think the fact that we're even talking about those is awesome, because it shows that already as sort of an industry, we're starting to think about, okay, let's make better use of the cloud. I think these two are different in that Google Chronicle doesn't charge by volume while Azure Sentinel does. So I think the Sentinel approach, I think there's a question of where they store data. I'm not sure that they store it in a true cloud native storage format under the hood, because they do charge by volume. And so that, again, puts you in this place of needing to pick and choose which data sets can you afford to collect. In general, I've heard that it gets very expensive for large data sets. In both cases, though, I think the biggest difference is that they are still silos of data off to the side from where the rest of your enterprise data lives. And I think there's a lot of value in consolidating security data into your enterprise data platform. And if your company has chosen to use Snowflake as that place where all your data analytics happen, where all the data comes together, there's a lot of kind of synergy that you can get from that. And so getting the security data into the same place is great. Just as an example, if you get all your log data into the same place where your HR data and your ticketing data is already being collected, now you can start tracking MTTR, stats like that. You can also start taking into account whether a certain user has been terminated recently, right? If somebody deleted 10 servers this morning, could be fine unless they were fired last week, in which case that's definitely a problem, right? So this idea of, well, let's put the data off in a different cloud native solution, that's still the right direction, I think, but where this is ultimately going to go is security analytics workloads get consolidated into the enterprise data platform, and security becomes another team that just uses this kind of central, cost-effective, well-managed centralized location.
Right. The other thing about the cloud-specific solutions is that, I feel that they might generally bias towards their own data, whereas we're trying to approach it in an agnostic way and, really take in data sources from anywhere, from any cloud. I mean, we also support pulling in GCP audit log data along with, the AWS CloudTrail data, for example. So we're spanning multiple clouds there.
That's a great point. That's a great point. Multi-cloud is the direction that everybody's going. I think it's important to plan for that. We have a question here about historical searches. So Jack, do you want to, I don't know if you want to commit to anything. We're live on the air, but do you want to mention something about that?
Which, are you talking about the one from?
Serban from Capital One is asking about, well, you're talking about real-time alerts. That makes sense. What if I want to run a historical search, and that has all sorts of applications in threat detection and threat hunting and applying threat intelligence, which may emerge months after the actual campaign, two campaigns that we may have recorded. So threat intel retro matching is another use case for historical searches. How do you see that at Panther?
Yeah, so we, in most likely our next release, or the one after that, we'll have the ability to create these scheduled searches with Panther. So the way it will work is you will define a query that will run on a schedule, and then it will send alerts out to your team if any results are found. And this will also open up the door for a lot of new types of detections where you might want to join other data sets, such as IOCs. So, if you load your indicators into your Snowflake, for example, you can join that data across the Panther view, which has all of those IOCs extracted, and then you could do your detection that way, and then you could just schedule that search to run periodically. So that's one way you could do it. You could also, actually also load it in Lambda, which is a little bit more intense, and I'm not sure I would recommend that as the best way to do this. But it's an option. I showed, in the slide here, what you can do post-incident or maybe during the incident if you want to continue to track that actor. Obviously, this list is going to expand a lot, and threat intel sources are generally really huge. But, if you're looking at a very specific set of attackers, this is a good way to do it. Otherwise, I would recommend that you preload it into a table in your Snowflake, and then you just join it to the Panther data.
And we have a few questions about threat intelligence. I think this will be the last topic that we cover because we only have a minute left. I'll use this as an opportunity to plug the Snowflake Data Marketplace, where we are onboarding new data providers every week or two. And already, if you want to get, for example, a list of Tor exit nodes that is maintained by IP info, you can go inside your Snowflake, request that data set, and it's just going to show up live and ready to use in correlation with the data that Panther collects to Snowflake. So definitely check out the data marketplace. And Jack, if you want to say something about threat intelligence, and then let's wrap on time.
Yeah. I guess I don't have too much more else to add than what I was saying before. I mean, today, there's no direct integration for threat intel with Panther. It's something that will become more prominent in the platform directly, most likely in the next 2 quarters. But as of now, we're relying on the underlying data store for the storage of the threat intelligence. And then, the team can pull in from whatever sources they have, whether it's like from, different groups that they're members of, or from other tools like crits, things like that, like pulling that into Snowflake. Yeah, that's really how it is today. And then
awesome. Exciting roadmap, and definitely a lot of data sets that are available, a lot of use cases. I want to thank everybody for joining us. And Krista, do you want to wrap this up? Oh, you're muted.
That double muting feature, I tell you. Omar, Jack, thank you so much for presenting. Awesome job. Great stuff. A lot of good questions coming in. So thanks to everyone for joining and for your time and attention. As I mentioned, you will get a recording of this tomorrow, your email inbox. So keep an eye out and reach out for any questions and to continue the conversation. So thanks again.
Thanks.